chapter is where chemistry starts to feel more professional, and you're gonna feel like, now I get why you need to study chemistry. It's because not just because chemistry is everywhere, because now everything gonna make sense. We will learn how to predict what happens in a reaction and how much product will form, and which of the reactants are the limiting reactant. So this is a very exciting chapter. I love this part. I think this is just come to highlight how I love chemistry. I use this a lot in my research, and I'm pretty sure that you're gonna love this. Of course, involves some math. I divide this chapter in like 3 parts, or 4. 3 parts and 1 extra video about how to balance equations if you still feel not comfortable with that. So let's start talking about global connection, the greenhouse effect, which is a natural process that keeps Earth warm enough for life. Sunlight enters the atmosphere, warms the surface, and the greenhouse gas traps some of that heat. But what happens when the balance shifts? That's where chemistry helps us understand climate change. So since 1860, scientists have observed a steady rise in atmospheric temperature and a 38% increase in carbon dioxide levels. Coincidence? Maybe. But one of major source of CO2 is combustion. So we have another source as volcanic action, but the chemical reaction that powers car or factory and even fireworks. Let's explore how these reactions work and how we can measure their impacts. So a chemical reaction is when substance transforms into new substance. Combustion is a special type. It involves oxygen and release heat. So think of burning wood, gasoline, or even magnesium in fireworks. The atoms rearrange and the products are completely different. We use chemical equations to describe reactions. They are like receipts. They show ingredients, which is the reactants, results, which is the products, and how much of each is involved. These equations help us calculate how much material or substance or compounds we need and how much we will get. So in equations, we use symbols to show physical states like solid, liquid, gas, and aqueous solution or water solution. That meaning that dissolved in water. These details help us visualize what's happening during a reaction. So here you can see a chemical reaction that is hydrogen and oxygen, and we have water as a product. So in the left side we have the reactants, and the right side we have the products. So we have here the stoichiometric coefficients. So the stoichiometric coefficients are indicating how many molecules, how many moles I have for each substance, compound, or element. And we have the state of matter that we talk about here. So G for gas, L for liquid, S for solid, and aqueous for aqueous solution. So, and then we need to worry about how to balance those reactions. So in this case here, I have 4, because it's 2 times 2, so I have 4 hydrogen over here. So in my right side, I need 4 hydrogen as well, and I do have. And I have here 2 oxygens, because when you don't have number in front of the molecule, we know that is 1. So, and here I have 2 oxygens, right? 2 times 1. So I have 2 oxygens in this side and 2 oxygens in that side. So it's perfect balance, and this comply with the law of conservation of mass. And just pay attention that you can never ever change the subscript over here. those subscripts tells me the identity of the molecule. So I know that I have a hydrogen molecule, and I know that I have a water molecule. So if I write like this, you know this is not water. See that I cannot change the subscript. The only thing that you can change on a balanced equation is the stoichiometric coefficients. Let me see if I can make this clear. If I have a face, like two eyes, a mouth, and a nose, so my molecule will be two eyes, one nose, and one mouth. Okay? So now I need two faces. And imagine if someone tells me that instead to tell me that I have two molecules of this that represent this face over here, comes someone and says like, okay, so we have a two, so we're gonna have four eyes, two nose, and two mouths. Look at this. This we're gonna be like this, right? So a completely different monster. So this is why you will not change the subscript, because that are the identity of the molecule. Okay? So let's look at methane burning. At first glance, the equation might seem so fine, right? When you look to this equation over here. But it's not balanced. The number of atoms on each side must match. We fix this by adjusting coefficients, but not the atoms. So this quantity of atoms over here tells me the identity of this molecule. Okay? So when you have to balance, you work with the stoichiometric coefficients. Right? So if I do have one carbon on this side, one carbon on this side, and I have 4 hydrogen over here, and I have 2 hydrogen on this side. So I can add the 2 over here. Now I'm gonna have 4, because it's 2 times 2, 4 hydrogen, right? And I have 2 oxygen plus, I have a 2 over here, so right? So I have 4 oxygens over here in this side. And then this side here, I only have 2. So what I'm going to do is add 2 over here. So now it's 2 times 2. I have 4 oxygen. Look at the carbons. I have 1 carbon and I have 4 hydrogen. So when you look to the products, I have 2 plus 2, I have 4 oxygen. I have 1 carbon and I have 2 times 2, 4 hydrogen. So perfect balanced, okay? So to show the reaction obeys the law of conservation of mass, the equation must be balanced always. If you don't know how to balance, please review the class about how to balance the reaction. So how many oxygen atoms are on the right hand side of the following chemical equations? So press stop in this video and try by yourself. So here I have 2 times 3, so I have 6. And here I have 4 times 2, I have 8. So when you add those two together, I have 14 atoms of oxygen. Good? So next question. Which quantity of or quantities must always be the same on both sides of chemical equation? So the number of atoms, molecules, or moles? The atoms. Remember, this is the conservation. So if I have 2 carbons in the reactant, I really need to see 2 carbons and the product. Doesn't matter if the carbons are forming a different product, and they will if there is a reaction, right? But the quantity must be equal on both sides. And next class, we're gonna talk about stoichiometry, which is so important in chemistry. And when you're gonna start estimate how much product you're gonna produce. Okay? So that's it. That's all. Bye for now.